All right, so here in this video, we're gonna try to write equations of our sine and cosine functions by looking at their graphs. Okay, so here's our first example. It says identify the equation for a sinusoidal function from a graph. I would probably start with identifying the midline of this function, and it looks to me, well, the lowest point is here, the highest point reaches to 1. So this would be my midline, which is y equals 0.5, which tells me that d equals to 0.5. Okay. Then probably we should choose which function are we gonna use, because this equation could either represent a sine function or a cosine function, shifted or flipped. Since my sine function, so this function has a minimum or an extrema point at x equals 0, right? So it's the lowest point on the graph. And so this is the pattern for the cosine function, even though for the cosine function, it actually has a maximum point here. But still, but still it has extrema at x equals 0. So I'm going to use the cosine function. Cosine x is what I'm going to use. All right, so we already determined that it's moved. We also determined that it's flipped, because for the regular cosine, here would be the maximum and point, and for this graph it's the minimum point. So the a coefficient is first of all negative, and what's the amplitude? Well, of this function, we're gonna there's two ways to determine: either the distance from the midline to the lowest point or to the highest point, or take the distance between the lowest and highest, which is 1, and divide by 2. Either way, we get a equals, absolute value of a equals 0.5. But because it's actually a reflection of the cosine x around this midline, we conclude that a itself is a negative. So it's negative 0.5. All right, so we start layering things here. Negative 0.5. That's our coefficient A. Okay, what about the period? So period here, it's the distance from the lowest to the lowest, or the distance from highest to the highest points, or one full cycle, is actually going to be 2 pi. So the period is 2 pi, which is standard for a sine or cosine function. So we will conclude that b equals 1. Okay, so there is a coefficient of 1 in front of x. And so we're not going to change anything here. What about the phase shift? I don't see any phase shift here, so we will conclude that c is equals to 0, no phase shift. Okay, and d is 0.5, so that's our function. Our function is y equals negative 0.5 cosine x plus 0.5. All right. I just wanted to explain a little more about the cosine. So the cosine function normally, I mean, translated, moved 0.5 up, would look like this. So I can see that the function that they gave us is basically flipped upside down. And that's why I concluded that A is negative. Now I want you to try to figure out the equation for this sinusoidal function. And again, pause here if you have to, and we're moving on. This is our next example. Identifying the equation again from the graph. Okay, so I will start with identifying my midline again, or the amplitude, or so let's start with the amplitude. So the amplitude, remember, it's your maximum point, which is 1 minus the minimum point, -5. Yes, you have to actually subtract a -5, divide by 2. So we have 1/2 times 6, so it's 3. The amplitude for this function is 3. What is, let's identify b. So the period of the function will give us b. And what is the period? It's just the distance between two highest points or two lowest points, whichever is more convenient. I want to use the highest. So here, this is your period. It's from 1 to 7. So the period is 6 units, right? From 1 to 7, 6 units. Remember the formula for the period. The formula is 2 pi divided by b. So if I know p, I can, when I plug it in, I will find b, right? So I have 6 equals 2 pi divided by b. So I'm going to multiply both sides by b. So I have 6b equals 2 pi. And then I'm going to divide both sides by 6 to get my b. So b is 2 pi over 6, or pi over 3. So b is pi over 3. All right. Next, so let's circle what we got so far. So we got a is 3. We got b is pi over 3. Next, let's identify c. Okay, and c is our phase shift. Well, first of all, are we using the sine function or the cosine function? It's actually up to you. Because if you're using cosine function, then your maximum is right here. And so I would say that your phase shift for the cosine function, well, this is where it's shifted right here, 1 unit. But if you're using the sine function, first you have to figure out probably the shift up and down and where your midline goes. So it would be much easier after that. So we'll just use the cosine function. And we just identify that the phase shift, which is the formula for the phase shift, is C divided by B, is 1. C divided by B is 1. Well, we just figured out that B is pi over 3. So C divided by pi over 3 is 1. Solving this, first of all, I'm going to turn it into multiplication. 3 over pi. Actually, I didn't have to. But anyway, equals 1. And now I'm going to divide out 3 over pi, or multiply by pi over 3, both sides. I will get C equals pi over 3. Okay, so that's my last one before last. I also need to identify D, and D is actually a midway between my minimum and maximum point. So, and the amplitude is 3, so it goes through y equals -2. Here it is. So I know that D equals -2. Now that I know all of my coefficients, I can write down the equation. And the equation is y equals 3 cosine B is pi over 3x. C is, and by the way, the shift is to the right, so this is going to be minus pi over 3 minus 2. And here's one interesting thing to note here, is that if you treated, for example, if you said that this graph is actually a cosine function, but it's shifted 2 units to the left and flipped, for example, then your B and your C's would change, right? Based on this assumption. And your graph, or your equation would look like this. It's -3 cosine pi over 3x. So the period does not change. The shift changes, the plus 2 pi over 3. And both of these answers are correct. They're both identical, will give identical graphs. And here's another crazy thing. As I mentioned at the beginning, you could actually use the sine function to express that same, to describe that same graph. So you could have a couple of those that are actually will give you the same graph. So there are many different ways to express this graph, and this is what makes grading very difficult. Okay, and now I want you to try one by yourself, and I want you to identify the equation for the sinusoidal function. So I think it crosses the x here at 1.5. So it touches the x-axis here at -1.5. Here it's positive 8.5. So this is 8.5. This is -1.5. Yeah, and it doesn't fall below the x-axis, and the tallest point here is 8. Pause here if you must, and this will be the last example in this video. In the next video, we're going to talk about how to sketch a graph from the equation.